Feeling how many fingers can you count right now? No. It's fine. Okay. Just allowing everyone to sit down. Welcome. My name is Proenc. This is my talk, Decoding Synthetic Monitoring, a journey from end-to-end UI tests to service level probes. I'm going to explain what I mean by this. I am a quality engineer at a company called E2E Health, and I come from Lisbon, Portugal, right on the other side of the peninsula. This is my blue sky tag if you want to follow me or something like that, or just send comments to me. And so the idea for this talk, well, the story that I want to tell you started a few years ago. At the company where I was working, we had an on-call team that essentially, they monitored our product 24/7. This was a team of engineers that are in rotation, and we have monitoring tools in place. We use a lot of honeycomb with alerts, and at any given moment, those tools may detect that something is wrong with our product, and they will bring up an alert for our on-call team who gets woken in the middle of the night. However, we had this issue where essentially, those monitoring tools, they require traffic to be present in order to detect that something is wrong. And because of the nature of the architecture of our, microservice architecture that we have a few pieces of it that are kind of like dedicated to specific clients. And those clients have their own users, and traffic is a bit, it shifts throughout the day. So imagine a product that people will use throughout the day most of the times, but when it comes at night or maybe on weekends, you see little to no traffic, and then that's highly problematic for our on-call team because essentially we don't know if the product is working or not because we depend on the traffic existing and events being fired up so that we can get alerts in case the tools detect that there's an error or if things are taking too long to respond or stuff like that. And back then, someone had this idea of, okay, if we have this problem of periods of time where we have no traffic, there's also all of these quality engineers here who are working on test automation and using Selenium and other technologies to build end-to-end UI tests. Why not repurpose those tests and run them periodically every half hour to generate traffic that simulates what a user is doing? And so in these off hours, like in the middle of the weekend or during the middle of the night, they're kind of giving us that pulse, that little bit of traffic that will tell us if the basic use cases are being successful or not. And that's what we did. A few years ago, we started using the same automated tests that we had for testing the product whenever we changed it for monitoring. We started running them every half hour against production so that we would get a better pulse to how things were faring. This proved to be such a useful approach to us that the automated tests not only generated the traffic and then we looked at the backend data to understand if something was wrong, but even if the tests themselves failed, that was basically demonstrating that in production something could be going on and they would alert directly an on-call person, hey, I just failed, so you should check if everything's working because this may be an actual problem, just the fact that I wasn't able to complete a complete use case. Of course that in this situation, you can imagine what becomes a highly critical thing when you have these tests running every half hour in production and producing alerts to a specific team. Flaky tests, right? And here it was really important, and don't get me wrong, I've worked with Selenium and these kinds of technologies for a long time. I think I started working with Selenium back in 2007. And we actually have a pretty stable set of end-to-end UI tests. I'm pretty proud of the way the tests are set up. But the thing is, just a little bit of flakiness, and I always believe that with UI testing, flakiness can come from from different places. We've had situations where someone just upgrades the version that we're using for some framework, and all of a sudden there's a specific part of the use case that becomes more flaky, and then we need to reanalyze and re-implement in a different way that lowers flakiness. Though we keep stability really well, there's always a little bit of flakiness, and usually low flakiness will be completely acceptable for testing purposes that you do a few times during a working day because you're testing things when specific events happen, when you're changing the product, when you're applying a configuration or something like that. But in a monitoring setup, even just 1% of flakiness, 1% of, let's say, false positives will be guaranteed to give you problems because it's going to wake people up in the middle of the night within the week because of the amount of times that we run these tests in production. So, at one point, we decided, we had the on-call team, they were doing a very good job in terms of understanding and reacting to problems happening in production, but their lives were miserable because they were being woken a bunch of times when they shouldn't. And so we decided it's time to find an alternative. And so I started looking into this topic of, okay, I'm using automated tests to exercise production every half hour. What exactly is this? And I found out throughout my research that this has a name. It's called synthetic monitoring. Looking at what exactly synthetic monitoring is, I found out one of the definitions is simulating user interactions to assess how the system behaves in production, which was exactly what we were doing. We have automated tests that are generating traffic, and at the same time they are asserting if a user can conduct in a happy pathway a complete core use case. It's what we call let's say, a type of active monitoring, whereas when we usually talk about monitoring as a whole, we think about passive monitoring, where you just look at what's happening that's coming from the world, what the users are doing, and how it's impacting your system. Instead of doing that, with active monitoring, you're actually introducing the events within your system so that you can look how it reacts and hopefully understand if problems are about quicker and in a more effective way. Another definition that I found was automated scripts that mimic predefined user paths to evaluate availability, meaning is the system up or down? Can you complete a use case or not? Functionality, transaction success, can you actually go through the whole use case? Can a user actually take their shopping cart and go to the end and pay for it? And also for performance, response times and latency. For us, it was more about the first two, but I will get more into that later on. Okay, once I understood that there was this whole discipline called synthetic monitoring, which was actually what we were doing, I started trying to understand what alternatives I may have, what were the leading practices and whatnot. What I found is that when you search for this, at least it's been my experience, when you search for this term online, you're going to find a lot of contents coming from vendors. You know, monitoring tools that will explain what synthetic monitoring is, and they will explain how their products can help you to conduct it. But I didn't find a lot of stuff about, you know, the craft of synthetic monitoring and when should you use it, when shouldn't you use it. Eventually, I found some pieces that I put together and formed my own understanding. And for me, reasons why we should use synthetic monitoring, and also hinting at reasons, maybe a justification that maybe you don't need to use synthetic monitoring, which I think it's important to understand. First, if you have low traffic or highly fluctuating traffic, which was, as I explained, our situation, we had a product that sees a fair amount of traffic throughout the working day, but at the end of the day, usually there's not a lot of users accessing it, just because of the nature of the business. When you have distributed systems with hard-to-trace end-to-end journeys, meaning that you see a lot of stuff in your monitoring, you understand that a service is behaving in a certain way, but it's hard to pinpoint exactly how that translates into a user journey that is happening through your system. If you have an automated script that's basically mimicking what a user is doing, it's much easier for you to correlate from start to finish all of the events that are involved in that. And finally, something also that I found was like when you have ambitious service level agreements in combination with the others. So for those of you who don't know what a service level agreement or an SLA is, it's basically a contract that you agree upon with your clients where you say, these are the levels of service that we're going to have. Usually it includes an uptime metric, like we assure 99.95% of availability, meaning that only in 0.05% of the time during a month, the system can be down for some reason. Why is this important when we're talking about synthetic monitoring? In combination with the fluctuating traffic, imagine that on a Sunday you have a user that accesses the system at 1 a.m. and everything's fine. He's able to do whatever he needs to do within the system. Then at 1 p.m. you have another user that accesses it, like little to no traffic, and they bump into an error. You're going to need to assume that your downtime was actually 12 hours because you have no way of understanding what happened between 1 a.m. and 1 p.m. And that's one of the ways in which synthetic monitoring is really useful for us because it gives us that pulse that increases the granularity and it tells us, well, actually the system started bumping into a problem at 12 p.m. It wasn't at 2 a.m. or something like that, which would be disastrous from a time span perspective. But of course, if you look at these, this also hints into situations where maybe synthetic monitoring is not the thing that's right for you. If I imagine a system like, I don't know, Netflix, that's at any given point in time, there's always someone somewhere watching a TV show on Netflix. They get a huge amount of traffic. Maybe synthetic monitoring doesn't make as much sense for them. So just take that into mind. Okay. I was already understanding that, yes, synthetic monitoring, we're definitely doing something that makes sense within our context. I understand what it's all about, but how are people doing this differently throughout the world? What can we find out there? How can I approach this other than the UI automation approach? And actually what I've found from people discussing the topic is that a lot of people went through the same story as we did. They had UI tests laying around, a lot of them built with Selenium, and they just decided to repurpose those to generate traffic in production. But for me, this approach has had a problem in my mind, which I'm trying to express here in this visual, which is, for me, when you're doing synthetic monitoring, there is a specific part of the system that we run, and we want to target with this kind of monitoring. However, the way we were doing that, there's also going to be another big chunk of the system that is not actually run by us, and we're not targeting with synthetic monitoring, and that's where the problems are coming from. Let me explain. What is the thing that I actually want to monitor for here with my synthetic monitoring? It's basically what I can run. It's whatever's running in our data centers, or in our case, in our cloud providers, where we have services, we have databases, we have infrastructure, and then there's like this back-end API that is serving the front end, which in our cases means either a web application, a website, or a mobile application. The front end, but that comes with its own baggage, right? It's a lot of JavaScript code running in those things, or it's mobile apps that react in their own ways. I'm not telling you that you don't want to monitor for, you know, that part of the story, but you're not going to do synthetic monitoring on that. Usually things that go wrong here, like the problems that you want to solve, is stuff like, is there someone somewhere in the world running this obscure version of the browser? Or maybe there's an obscure Android device in which our app misbehaves or something like that. For that kind of monitoring, there's other tools that you can use, tools like Sentry that essentially detect stuff happening at the local level and then just call home sending data to Sentry so that we know that there are logs about stuff that we never imagined may be happening. But with synthetic monitoring, essentially, you are, building a framework, building automated scripts or tests with Selenium or other technologies like Playwright and Cypress. I promise this is the only slide where you will see these logos in. And essentially, you have these technologies handling the whole front-end part just to generate the traffic that we want to monitor at the entrance of our APIs that then go into the services that we have. But when you're doing this, this is actually simulating something that in real life we're not running. We're not going to bump into obscure device problems here because we're always running the same mobile app, or we're always running the same browser with the same version. So, this is a moment where I think we should just pause, and I should make this disclaimer. You're probably wondering right now, João, did you actually come to Selenium Conf to tell us not to use Selenium for something? Well, bear with me. I am in no way saying that you shouldn't do UI automated testing. I'm actually a fan of it, and I own a UI automation set at my company, but the way we strategize around that is that we thought that within our context, it made sense to run those very valuable end-to-end UI tests for testing whenever we change the product, and we still rely on them highly, and they produce a lot of value for us. And even if you don't think that in between the divide of testing and monitoring, maybe using UI testing for doing synthetic monitoring in your context is something that works for you. That's fine. For us, it wasn't, and so I wanted to find a different alternative and share that alternative with you folks. So I hope that this is fair enough for everyone, okay? Okay, so how can we do this differently? And the idea for the thing that we put in place came from one day I was talking to the head of SRE at my company. SRE, Site Reliability Engineering, people that know their observability, they know monitoring tools, they know how these things usually are done. And I asked, hey dude, how would you do this if you lived in a perfect world? And what he did is that he explained, well, usually where I come from, these things are done using something called Prometheus probes, okay? Prometheus is a monitoring tool. Even though they are called Prometheus probes, it's not exactly something that's proprietary of Prometheus. It's more like a standard, okay? It came from the Prometheus world, but actually you can use Prometheus probes or Prometheus-like probes with other tools. We're not even clients of Prometheus. We actually use Honeycomb and OpenTelemetry, and we achieve the same effects. But bear with me, I will try to explain what exactly this setup does. So if you imagine that you have a monitoring tool like Prometheus that's collecting data from production, and you're monitoring that data and producing alerts and observing it and exploring whenever you have to troubleshoot something, you also have a mechanism that allows you to call a probe every X minutes, and it's bundled in. And what it does is that it's going to use a language called the multi-target exporter pattern. We don't need to go deeply into details of what that is. Just imagine it's a standardized language for probes to communicate with systems. And it's going to call it a probe, and Prometheus offers you, out of the box as an open source project, the most basic probe that you may have, which is called the black box exporter. And what it does is that Prometheus is like, hey, black box exporter, please go check if that website in blue here is up or not. And what this thing does, okay, if it's telling me to probe this website, I already know that I need to do this HTTP request to it and expect a 200, a OK status code to come back. Maybe I can also, you know, check some things within the response that I get, if I get a specific payload or not, but that's pretty much it. It's a very simple thing that essentially, whenever you tell him, hey, please probe that thing over there, it will reply with information regarding success and performance back to Prometheus, so that then it can collect that data and, you know, not only get the traffic that's being generated within the website itself, but also get the results from the probe itself. And as I was saying, we don't use Prometheus for this. We actually use Honeycomb, which is a different monitoring tool. It's a competing monitoring tool that we prefer. And we use something called an OpenTelemetry collector. I'm not going to go deep into that as well, but OpenTelemetry is just a standard that people within the monitoring world use to build these things, where you basically can interswitch different vendors, as I'm demonstrating here. Okay? And the OpenTelemetry collector does that function of, I'm going to call that probe every X minutes so that I can collect information from my website or my endpoint or whatever I want to probe, okay? And so what my friend and colleague was telling me is that what I would do is that instead of having a very dumb probe that is only able of doing an HTTP request and get a response back, I would create something that's much more bespoke to our use case, and essentially doesn't do one request to the backend, but does a sequence of requests that will totally simulate what the UI is actually doing, what the front end is actually doing. So in his mind, he would replace all of that layer that we have with the front end actually running and a UI automation test set exercising the UI with a bespoke Prometheus probe that would simulate exactly what are the requests that we want to do to the backend. Okay? And this brings us a number of advantages that I will explain a little bit later. Once he explained this to me, I had a problem in hands, because I needed to set up a framework for different teams within my company to be able to produce these bespoke Prometheus probes. And I have different teams that have different contexts within the company, and they deal with different technologies. Some teams are more attuned to the backend. They work in Kotlin, and they deal a lot with MongoDB. Others are more like front-end attuned, and they do a lot of JavaScripting and TypeScripting and all of those technologies. The problem is that if I build a framework attuned to the backend, Kotlin and whatnot, the front-end folks, they will have a steep learning curve. The alternative is me having to maintain two different frameworks for the same effect, and that's not going to go well. But I started thinking, what would be ideal in terms of having everyone producing these Prometheus probes? And I noticed something that was kind of like pervading and common within the whole organization, and I could see it in almost all teams. Almost all of the teams were already using API testing tools, okay? So, API testing tools, the most famous one is probably Postman nowadays. Back in the day, I remember using something called SOAP UI. In our specific case, we don't use Postman, we use Bruno, which is basically an open source counterpart, okay? Just to get a feeling, who here has ever heard or used any of these tools? Can I get a raise of hands? Okay, so most of you folks know what I'm talking about, and you probably know how it's a easy to use guided user interface for you to test APIs or even to design and develop APIs. And the thing that I found that was a major source of value for what we were trying to achieve is that I had a lot of developers that already had a bunch of collections of requests that simulated what the front end was supposed to do, because they use that to test themselves, especially from a back-end perspective, or even to communicate with other teams explaining, this is the flow that I expect from the API when it's implemented in the front end. Wouldn't it be cool if we could reuse all of those collections to create a probe? And so, an idea was born of, okay, instead of using the black box exporter or having people implement things out of scratch, why don't we create something that's based on Postman? Well, in our case, at the beginning it was Postman, then we migrated to Bruno. So basically, was something we called a Bruno probe. Essentially, it's a probe that allows you to run collections, the collections that you already have. So it will receive requests from a system like Honeycomb or Prometheus saying, hey, please probe that website, or please probe that service. And what it's going to do is, underneath the hood, run a collection that you've already fed it to simulate not just one request, but a sequence of requests that make sense and represent a full transaction, the same way you would if you would exercise the system through the UI. The funny part, and this may be useful for any of the folks here that find this interesting, is that this wasn't a complete original idea. Once I had this idea, I found that other folks already had the idea. So if you're using Postman, and a lot of people here probably are, there are already 2 open source projects that essentially implement this idea. And I will share the slides and the links later on. You can follow up on those if you want to play with these things and put something together that's similar to our approach. In our case, we had to develop a Bruno probe, but it's basically a lightweight layer that essentially allows you to fire up a Docker container of something that knows how to receive HTTP requests, telling, hey, probe that place over there, and then underneath the hood has a number of collections that will be run, and then feed the results back to whoever called it. Okay. Maybe this was a bit theoretical, so let's look at an example of the process that I went through, but I'm going to use a way more simple, let's say, test subject for the effect. Okay? This is kind of a demo. I'm not going to do any live coding, but you're going to see the whole process I went through. We're going to use something which is a testing website, testing app from Mark Wintrigum, Automation in Testing .online. Thanks, Mark, for allowing me to use your test app as the subject for this demonstration. It's basically a bed and breakfast booking tool. Okay, so everyone here, I guess, can imagine the kinds of things that you can do. In our case, we're going to book a room into this bed and breakfast. And I implemented a UI test using Selenide and Selenium under the hood that actually does that. So we're going to go into the web application. Now I'm going to go into the calendar because I need to select a number of days where I want to book my room. I've already selected them. Now I'm going to fill out my details over there. And then I'm going to press book. And there you go. I have my booking. It's successful. Because I want my test to be self-contained, now I'm going to go into the administration console. I'm logging in, and I'm going to delete the booking I've just created. I'm looking for the booking finished that ends with Proenc in the name, and I just delete it. And this is the test that I have. And this is kind of like simulating a core use case of this specific web application, which is people can go in, they can search for rooms, they can book for specific dates, and then in the end, an administrator can cancel a reservation, okay? What I did afterwards is that, okay, now that I ran this whole scenario with my UI automation, I'm going to check all of the requests that were happening in the background to my backend services or my backend API to capture all of the things that were happening from a backend perspective, because this is the thing that I want to exercise from a synthetic monitoring perspective. The thing that I do is that I start exporting all of these requests in curl format. Curl is just a tool that you use in a terminal to run a specific request. And Google Chrome DevTools actually allows you to do that. You can just export all of these requests in their curl format, and then you can run them in a terminal if you want. And they will be very much similar to the requests that came out of your browser to the backends. When you go to Postman, or in our case, I'm using Bruno, what I do afterwards is that I just import those curl requests so that I get them set up. Oh, this is really hard to read with all of the light, isn't it? Yeah, is it possible to shut the lights or something? No. No. All the buttons. Yeah, this is probably better. Is it better like that? Okay, cool. Sorry about that, folks. I hadn't realized that you were having troubles in reading. And so I import them directly in Bruno, and then you can see that you start having all of the requests there that kind of make sense. You're accessing the website, you're getting something called branding, and then information about a room, and then you post a booking with the information that I had. Here's the payload, my name, my last name, check-in and check-out dates. And you can simulate the requests within Bruno. It's the whole use case that you saw in the UI, but translated into the backend API requests. Afterwards, we can run this as a collection in Bruno or Postman. You've probably seen this kind of thing. One thing that I just want to point out here is that you can see how fast this is when in comparison to the UI test, right? The other UI test that you were observing probably took like 30 seconds to complete, whereas the backend requests are taking 3 seconds to complete. And this will be important later on, and I will explain why. Okay, now I have a collection that I can run against the backend that simulates what's coming from the front end. Let's set up a probe that is able to run that under the hood. And this is the thing that I have. I have the probe as a running container in my machine for demonstration purposes, and I'm calling it, telling it, hey, please probe target AOT, automation and testing, and it already knows, okay, if I want to target that target, I'm going to run this specific collection. This is the multi-target pattern, exporter pattern. As I said, we don't really need to go into detail here, but things that are interesting, this is the language that all of the monitoring tools are going to understand using OpenTelemetry collectors. There's something called probe success here, telling it has a value of 1, which tells the system, yes, I was able to successfully probe the thing. And actually what I did is that I ran all of these different steps, which are all of the requests that form the complete use case. All of them got a 1, which is a successful status. And there's even, I can even do assertions on these things to make sure that I get the right payloads and whatnot. I also have duration in seconds, which gives me performance. So this whole thing took 3 seconds to run. And for each step, I also have how long it took to run. And this is that common language. I can just take this information and feed it into a dashboard. And this is one of the dashboards that we have set up in Honeycomb, just for you to get a feel of what I'm talking about. We are feeding this data there, and then the type of metrics that we focus in dashboards that we look at, it's essentially if the probes are being successful or if they fail, as you saw before. Also the probe performance, because we are collecting that data, and it's actually really useful. Even this example is a good example that happened to us, where all of a sudden the system started behaving way slower than it used to, and it was immediately apparent by the data that we were getting from the probes. But also something else which is really, really powerful is the fact that we have the probing or the testing data ending up in Honeycomb, which also collects the data coming from the backend, being errors or being all of the trace data of all of the things that are being called underneath, allows us to look at all of these things together in the same tool. And that's really, really important. This is something that happened to us. At one moment, when we were setting all of this up, we had a testing environment running our product, where we were using the 2 approaches in parallel. We had the UI automation tests running against it and producing production traffic throughout the day. And we also had the probes producing the same kind of traffic throughout the day as well, and we could compare both approaches. At one moment, during a working day, all of a sudden, all alarms started going off that testing environment was down, in the sense that both the probes and the UI tests were failing. Immediately, myself and a colleague of mine, we went into the probes dashboard, and we could see, okay, I can see that the time the probe takes to complete has skyrocketed, so something's up. I can see that there's a specific request that actually generates a PDF report, is taking way longer than it did before. It used to take 5 seconds, and now it's taking 30 seconds and timing out. And I can also already jump back into the backend data that's telling me the exact same thing. I just took 30 seconds to take care of a PDF generation, and I can look at the trace, oh, okay, there's a problem with an underlying library that's crashing with an out-of-memory error. And this was like in 5 to 10 minutes, we could go from a probe alert to understanding what exactly was the nature of the problem. At the same time, there were a few colleagues of us that were looking at the UI tests, and their experience was a bit different. They went to Jenkins, they saw that the UI automated tests were failing, they tried to understand more or less where it was failing throughout the user flow. They went into the source code. I think one of them was trying to simulate the same thing in their own machine so that they can look at the backend requests, so that they can get a trace ID to then go to Honeycomb and essentially come to the same conclusion as we did. And by the time we told them what was happening, they were still basically in this step. And I'm a big fan of observability. I'm a tester, I'm a quality engineer, but I'm also really interested in the observability world. And one of the things I always say is that hopping means friction within the observability world. If you have to hop between different contexts and different technologies to understand what's going on with your system in terms of the logs that you obtain, that is going to vastly increase and be a big hurdle for your capacity to troubleshoot problems in production. Sometimes we can't escape it, but when we are able to escape it, which we were able to with the probes approach, then it becomes really valuable. This is a quote from Charity Majors. She's one of the, one of the most well-known people within the observability world, and she's been talking about this idea that the new age of observability, observability 2.0, is all about having one source of truth, which means having one data source for all of your data and several views. And in my quality engineering mind, that means having probing or testing data next to your production, your backend service data that allows you to correlate things in conjunction, which was exactly what we obtained here with this probing approach that I've just described. Okay. Another thing that I also want to cover, because before I wrap this up, with great power comes great responsibility. No, I'm not going to use this quote. What I want to say is, with great speed comes great flexibility. As you saw before, because I mentioned, we went from these UI tests that basically took 30 seconds to run in the example that I gave you, and we reduced that to 3 seconds. In our real live UI scenarios that we have and that we are running, it's more like they take 3 to 4 minutes to run, and we have reduced them to 10 to 12 seconds. That is a complete overhaul and a revolution of the things that we can do from a monitoring perspective, especially when it comes to the sophistication of alerts that we can put in place. Because when you have something that takes minutes to run, and in our case we were running it against a number of targets, meaning that you can only run this full automation set every 30 minutes or something like that to generate this traffic, when it fails, a human being should look at it, because you're not going to do a retry and wait I don't know how many more minutes before trying to realize if a problem is at hand. But if you reduce that time to something like 10 or 12 seconds, then you can have a higher frequency when you're monitoring, when you're probing the system. And so maybe you just wake up someone in the middle of the night if 2 out of 3 probes fail, instead of failing immediately. It gives you way more options when it comes to having better alerts, so that you don't exhaust the poor on-call fellows with false positives. And so that is a major source of value that we got from this approach. Okay, main benefits of the new approach, as I was saying. Having the probe and the backend data in one place is very good. It vastly reduces the time it takes to troubleshoot something. Faster probes allows us to have better frequency, as I've just explained, more sophisticated alerting. There's also the fact that we have a thinner automation layer. We don't have the front end anymore. We don't have the automated tests in there anymore. And it's actually more stable when you're doing these things at the API level. And finally, there's also something which is more socio-technical in nature, which is the team that actually owned the UI automation tests that were serving both the purpose of testing but also monitoring, was really appreciative that we lose the monitoring responsibility, because it was giving them a lot of constraints in the way that they could evolve the tests themselves. In the sense that maybe they wanted to add some stuff in or eliminate some stuff, but there were always limitations to the things that they may decide to do, because don't forget that these automation scripts are used for monitoring, so we need to maintain them in their current form, and they need to be as fast as possible in order for us to have a system that is that we can use. And they were really happy with the fact that we're using a different approach for monitoring, and we can, enhance our automation set for the purpose that it was built with. Thank you.
Yeah, that was a great talk. Thank you, Joao.
Thank you.
So we are open for questions.
Hello, thank you. It was amazing. I have a question. This kind of monitoring testing you're running, where do you usually run them? Is just for QA testing environments, or you also run them in production?
No, the idea is to run against production.
Against
yes,
production.
to generate the traffic against production, because our on-call team is only going to be alerted about stuff in production. And even measuring SLAs and all of that only makes sense within production, yes.
And I had another question.
Yes.
In my case, for instance, I don't have EUI testing. I just have a whole backend API testing, and we have a full coverage. So how we can integrate the work we already have, making all those API requests, and so for having the monitoring step, is it, well, I suppose it's possible.
Yeah, of course. I mean, if it's something kind of similar to what I was describing, in the sense that you already have these test sets that are basically exercising the APIs. I don't know exactly what you are using for that effect, but you could repurpose those to generate traffic in production and monitor for that using a Prometheus probe approach, if that's the kind of thing that makes sense for your company and in the context that you're in. Don't forget the things that I said at the beginning, which is, okay, what kind of business, what kind of traffic do we have? Does it make sense to do synthetic monitoring? Does it not make sense? Because it really depends on the case that you have.
Okay, thank you.
Yep. More questions? Aurelian.
Hey.
Hi.
So, of course, dividing by 10 the execution time is great, but what do you think about having the alignment or missing the alignment with the front end? Because in this solution, if front end will change the API calls, how can you guarantee that your monitoring check will still do the same thing at the front end?
Oh, so one thing that the teams that are now using this, they do is that there is a risk there, which is, okay, the UI has the advantage of, if the UI is working against the backend, automatically my automated tests are valid for using against production. Whereas if all of a sudden I change something in the UI and the way it interacts with the backend, maybe we don't remember that the probes exist and we need to change the probes as well. In order to counter that risk, what teams started doing is that they also have probes running in development environments. They're not running them every 30 minutes or every 10 minutes. They run it like twice a day or three times a day, so that they detect whenever they produce a breaking change in the APIs that they didn't accommodate into the probes, and that they need to do that rework of the probes, preparing for a new release version or something like that. Does this answer your question?
Yes, thank you.
Thank you. So we are in a tight schedule for the next session.
I'll be around. If you have questions, just approach me and I'll be happy to answer if I can. Okay? Thank you so much.